Probability of compound events is when you have more than one thing happening, you multiply each of those probabilities. And we always put it in fraction form. Sometimes you might see it as like a percentage or a decimal, but we are going to do it as fractions. So the first scenario we have here says you flip a coin, then you spin a spinner numbered 1 through 6. Find each possibility. So let's do something like, we'll do number 1. You're flipping a coin. How many possibilities are there? There's 2. There's heads and tails. So out of those 2 possibilities, what's the probability I'm going to flip heads? That would be 1 over 2. We're going to multiply that by the spinner. Now the spinner is numbered 1 through 6, so there are 6 possibilities. It says what's the probability, then we're going to get an even number. So how many of those 6 are even? That would be 3 of them, right? 2, 4, and 6. So we say 1/2 times 3 over 6. Now, just like we did when we were multiplying fractions, you're going to want to simplify early if you can. It just saves you a lot of big numbers. So like 3 over 6, 3 goes into 3 once, 3 goes into 6 twice. Now we can just multiply across the numerator and across the denominator. 1 times 1 is 1, 2 times 2 is 4. Great. The rest are very similar to that. So let's try another scenario. The letters from the word trigonometry are written on 12 slips of paper and put into a hat. So we're drawing out of 12. You draw out one letter, take a look at it, and then you put it back in. So there's going to be 12 in there the second time you pull out a letter 2. Find the probability you'll draw in the following order. So let's say, let's go with number 10. With the probability we're going to get an O the first time and then a vowel the second time. Remember, there's 12 slips. We take one out, we look at it, we put it back in, so there's going to be 12 the second time too. Now, how many of the letters of trigonometry are O? I want to see 1, 2. So 2 out of 12. We put it back in. Then we want to know the vowels. So we have the 2 O's, the I, and the E. We're not counting Y. So that would be 4 out of 12. Great. Simplify if you can. 2 goes into 12 6 times. Over here, 4 goes into 12 3 times. So we're left with 1 times 1 is 1. 6 times 3 is 18. You can't simplify that anymore. Okay. You have a bag of candy left over from when you went trick or treating. In that bag are 5 chocolate candies, 3 fruity candies, and 2 circus peanuts. So, to figure out the total possible outcomes there, 5 plus 3 plus 2 would give you 5 pieces of candy in your bag. You reach in and grab 2 pieces of candy. You're not looking. Find the probability of getting the following combinations. So, let's go with 13. We said that there were 10 pieces of candy in there. Now, of those 10 pieces, the probability I'm going to get the chocolate one the first time, there are 5 pieces of chocolate. Great! So I have a 5 out of 10 chance of getting chocolate. I don't put that chocolate back in, so are there still 10 pieces of candy in there? No, there's only 9 left in there. Plus, I already got one of the chocolates, so there's not 5 chocolates left in there, there's only 4 chocolates left. So you got to be careful of that. Now let's simplify. 5 goes into 10 2 times. We can even do now the 2 with the 4. 2 goes into 4 2 times. So the numerator, we have 1 times 2 is 2. Denominator, 1 times 9 is 9. So the likelihood you're going to get 2 chocolates is 2 out of 9. Let's go to the last scenario here. There's so many people that care about you. Some of them were asked to give their favorite things about you. 20 people said you were kind. Oh, isn't that true? 15 said you were helpful. I thought so. 8 said you were hardworking. And 7 said that you were considerate. So if you add up those 4 numbers, you come up with 50 people that wrote nice things about you. So let's find the probability that you just randomly drew out 3 sheets of paper in a row. You didn't put them back in. The probability that you were considerate, how many of the 50 were considerate? 7. 70